Okay, welcome back class. Let's get it started. In today's class, we will discuss about the process itself. I mean the design process. What we are interested in this class is not how we step by step design a ship or any other ocean systems, but we kind of assumes that you guys have a little bit of or some of experience in ship design already, and based on that we are now focused on the design process itself for today's class. But as far as I know, about 1/3 of this class have many experience in ship design or other offshore systems design, but other than that, no experience at all. So I understand that, so I will briefly cover the detailed step. I mean the basic steps of the detailed design of ships and ocean systems throughout this semester, a little bit by a little bit. Okay. First of all, this is Advanced Ocean System Design course. So first thing first, we got to know or we got to define what is ocean systems. The most famous ocean system is a ship, right? And there are a variety of ship types. The first slide shows the cruise ship. This one shows some military application. Upper left corner, aircraft carrier. Upper right corner, catamaran type stealth ship. And the name is Sea Shadow. I believe, have you ever watched 007 movie? It was on that movie. Okay. The lower left corner is a high-speed catamaran. I think it's used for the deployment of army force briefly all over the world. And the lower right corner is the cargo is a warship, USS Cole, and the carrier is also another ocean system, heavy lift carrier. It's a ship, semi-submersible. I mean the submersible ships. If you remember, there was a big terrorist attack in Gulf of Persia, if I remember correctly, and the USS Cole was attacked and damaged. Okay, but there was no nearby shipyard to repair that USS, the warship, so US Navy decided to carry that ship over to their own shipyard using those heavy lift carrier. So it works like that. The ship is floated, USS Cole, and heavy lift ship carrier goes like that by putting ballast water inside of its own hull, raise it, and go under the USS Cole, and then it lifts up and carries. Okay? Anyway, even though it can submerge, it's a ship. It only has different design requirement or missions. This is also another ship. It's a pentamaran. That part. Pentamaran means, penta means 5. Okay? Catamaran means ship has twin hull. Right? Conventional ship, which has a one single body, is a monohull ship. Monohull, twin hull, catamaran, and if there is a three hull, we call it trimaran. If it has a 5 hull, it's a pentamaran. I'm sorry, this is trimaran, I'm sorry. So it has 3 different hulls, okay, and this is another famous ocean example of ocean system, military submarine, and this is also another very famous offshore oil platform jacket structure, and this is it's a kind of emerging market for a Korean shipbuilding industry. It's FPSO, floating production, storage, and offloading unit. It is basically oil petroleum production factory floating on the sea. Okay? All these are just ocean systems. So please keep in mind and keep asking yourself, do you see any similarities among all these systems? Actually, it's a more detailed diagram of how this FPSO system works. This shows FPSO. This shows production rigs. I think it's a TLP type, tension leg platform type. All are floating on water surfaces. And there is another ship there. It's a crude oil carrier or oil carrier. It will carry the oil produced in this FPSO to deliver. But as you can see, this is not the whole system of this oil production. This is not all the system. All things are system. They should interact with each other. They should be considered in their earlier designing phases. You have to think of another ship when you design FPSO and any subsea equipment and other things. So that's why we call it systems, okay? And so far we talked about kind of huge systems, huge ocean systems, but there are also smaller size ocean systems as well. Torpedo type unmanned underwater vehicle, box type unmanned or remotely operated vehicle, and it's some I don't know, crab or lobster robot for some underwater exploration or maybe just for fun. And these are actually the picture taken by this one. This torpedo type unmanned underwater vehicle are actually performing some functions to help us, like searching the seabed to find the submerged World War II airplane. So, and it did, okay? So thinking of it, it is ocean system does not consist of steel structure and fluid dynamics, but it also considers and have to include all this sonar technology, sensing, controlling, and other things as well. Because this functionality, this feature is essential part of these ocean systems. Okay. Another fun but serious example is the sea launch. They are in pairs, consist of this ship here and this semi-submersible launch pad. Have you ever heard of 무궁화 satellite system? We Korea has several of them, and I believe if I remember correctly, Mugunghwa satellite number 3 was launched on this sea launch. Okay, they are a commercial company who earns money by putting your satellites on the orbit, and the key idea is okay, let me ask this question. On Earth, where is the best location to launch a rocket? Yes, Simon?
Ecuador?
Exactly. And the reason is?
Because there is no spring.
Yes, yeah. Yeah, because Earth is rotating, and those forces helping the rocket launch has its maximum value at equator. But the problem is, if you remember the globe, there is not so much of land on equator. Usually there are a lot in Africa and some South American continent, but it is some kind of political issue, so it is not that easy to ask, can I use your backyard to launch my rocket? Then everybody will say no. But on sea surfaces, there is no nation. It's just free sea. So they brought up this brilliant idea. Okay? It's a kind of new concept. It works like that. They bring the rocket with this semi-submersible. They purchased the old oiling rig and converted it to this launch pad, and they go together. But the semi-submersible speed is relatively very low compared to this ship. It should start earlier. But anyway, at the launch site, they meet together, and because launching is a very dangerous operation, so all the personnel on the rig transport to the ship, and ship just move away, far away from this oiling rig, and everything, all the operation, all the launching operation is performed remotely, and all the control tower is on the ship. Okay, that's the system. The good thing is, of this, one more good thing of this design is that the thinking of the thrusting power, the heat, is enormous. If you construct a launch pad on the land, you have to figure out some cooling features, because if you don't do it, the heat, the pure heat will melt away all of your structure. But in this design, in the oiling rig, the launch rig, looks like this. Okay, and if you see this oiling rig from the sky, it has this shape. So as shown on this one, the rocket is transported horizontally, but for the launch, it is erected like that, exactly like this. All of it just will touch the water surfaces. You don't have to cool it down. Save up much of the construction, energy, and other things. So new concept can change pretty much everything. Okay. Okay, this is floating wind turbine and wind turbine farms. It is not my design. I just downloaded from internet using Google search, and there are several of this design. Some are using the TLP design, tension leg design, and some are using just the conventional mooring design, and some are using a semi-submersible type design, grab this semi-submersible type of structure and put as many wind farm here. Don't know which one is better. It may depend on the actual ocean side, because every ocean has its own characteristic. Anyway, this is what you're going to do throughout this semester. Okay, as a summary, surface ships, underwater submarine, offshore plant, machinery, energy harvesting system, devices, and even ports, harbors, breakwaters, pipelines, underwater pipelines and everything, or subsea devices and equipment are the famous of the ocean systems. And I'd like to define ocean system is some system that performance of the system is heavily related to the ocean environment. Okay? So, any question, comments so far? Okay. Let me ask a question then. Have you ever heard of a tidal generator, electricity generator, utilizing the tidal water height differences as a potential energy? Is this ocean system? Yes? 2, 3. Okay, no? Okay. Why? Why no? Dong-seok?
It's relative.
Oh yeah, you may.
위치에 가까이 있는 오션 시스템이라고 제가 생각하기에 저는 먼 바다에서 그걸 잘
Okay, you got some kind of point. And Gusto? Reason? He said it is too close to shore. To be an ocean system, it should be a little bit far from the shore. And your reason is? Gusto? Same? Okay. Since we are in the engineering school, when we call ocean environment, we mean that the mechanics of ocean environment. Okay? So there is some mechanical characteristic of ocean environment. Random waves, currents, all dynamics and winds and other things. If those mechanics plays a major role in your system design, or those mechanics are keys to understand your performance of the system, then I would like to define it as a ocean systems. So there is no clear answer. Okay? I just wanted you to think about. You got to understand the ocean system by understanding system and understanding ocean itself. Okay. Now it is time to discuss about the design, and basically there is no clear answer like equation solving or other things like that. For example, the solution to quadratic equation, then there is only one answer, right? Everybody will agree. Okay, but for the design process, there is no single absolute truth answer. But this design spiral approach is accepted by majority of this industry. Okay, design is basically a determination process. Determine what? Well, for example, if you are going to design a ship has some kind of its own characteristic. It's a product, a system. System has, well, parameters to determine. For example, length of a ship, breadth of a ship, depth of a ship, or draft of a ship, self-weight, size of the engine, propeller diameter, and all other things. Required number of crews, height of your deck house, volume capacity of your cargo hold, and all other things are just parameter to be determined throughout your design process. And in order to design it, you got to determine it. Okay? Without it, you cannot design. But it is darn hard because there is no single absolute equation to answer your question. You have to guess first. Okay? But guessing is kind of a dangerous job. And you cannot guess everything at the same time. So usually people follows these kind of steps. First, you just understand or describe or summarize the owner's requirement. What's the purpose of your ship? What the ship you're designing, what this ship should satisfy. There must be some kind of requirement of an owner, like this ship should be able to navigate at 25 knots maximum, and not and it should be able to carry this much amount of cargo, and it should be able to go from Busan port to LA without any refueling and the like. Okay, and the second one is a comparison of design. This one is could be a little bit confusing, but because this is a not a make to order make to stock industry. It's a not mass production industry. So it's a make to order industry, 주문 제작 system. So it is done hard. So the first step is doing some kind of literature survey. Are there any existing ship which has similar capacity, similar mission, or similar something? And if you do the research, and you will be able to accumulate some kind of data, and by some mathematical manipulation, usually regression analysis, you can safely guess the value. For example, this kind of question is really hard to answer. If you ask, what would be length of your ship? What would be length of your container ship if the capacity should be 10,000 TEU? How can you answer? There is no absolute equation to answer those kind of questions. But if you do the literature survey, look through the existing ship, then you can get some kind of tendency. And by grabbing those numbers, well, 350 meter or something is a kind of a very nice initial guess of your design. Okay? It assumes that existing system is relatively well designed. Okay? After that, basic dimension calculation and general arrangement and other things should be followed. And by following this spiral, you will accumulate more data of your design. At the first time, you even don't have the length information, but you guess the length, and based on your guess, you can determine the next thing. Okay? And the next thing, and the next thing. So once you accumulate it, everything is your guess, composition of your guess, so that design will not be a good design. So you do the iteration again and again and again. Okay? But from the second iteration, now you have enough information, even though the quality of your information is not that high, but compared to the first iteration, at least you have information. Then you are supposed to apply another thing to refine your information or recreate your information. At the first stage, you have nothing. You just guessed roughly from regression analysis. But once you have everything, even though it is kind of conjectured value, you can apply a more sophisticated equation to check and evaluate your current design is better or something. And if you iterate again and again and again, hopefully it will converge into the optimal design. But it is not the usual case. For unexperienced designer, the spiral usually go the other way. Okay? Anyway, that's the design spiral, and I'd like to mention one very important thing. This is one example, DDG-51. I think the ship on this picture, the name of the ship is Alberic, one of the old Aegis warship. Because it's made to order system, the first ship cost more than the following ship. According to the data, its price is about $1 billion US, but the following series ship is 30% less than the first pilot ship. NAVSEA is U.S. Navy's naval surface warfare, naval surfaces something. In Korean the Korean counterpart is Johamdan. Typically views the ship designs in the following 4 phases: feasibility or conceptual design, and then preliminary design, and then contract design, and then construction design. As the time flows in this direction, as you can see, there are time or effort requirement exponentially increasing. Okay? Feasibility or conceptual design, it requires on the average of 60 man days. Okay? 1 man day means effort of 1 man working full day, usually 8 hours. Okay? If your 2 men is working on the same project, it will be completed arithmetically 30 days a month. Okay? Feasibility or conceptual design, it is a stage of refining the design itself. I mean the design concept itself. You don't have to have the detailed information of major dimensions and other things. Just thinking, is this concept will work, or is this concept technologically feasible or something? You are supposed to answer those kind of questions at that stage. For example, sea launch. Somebody brought up some idea. Let's launch a rocket on an equator, on sea. Let's launch a rocket in this way to one control ship, and oil leaks, and directly the blast will directly hit the water surfaces and the like. All these concepts, and groups of engineers will discuss over and over and again. And is this technologically feasible? Well, maybe so. That's the result. That would be the result of your feasibility test or conceptual design. You may have to do a very basic calculation, such as, is this pontoon is large enough to lift by buoyancy all this weight of the rocket and other facility or something? Is this design will withstand the wave? Because at the launch you have to be very stable, right? And the like. You are supposed to do very brief calculation, even though in the conceptual design. In the preliminary design, it is usually the limit in university situation we can do until this preliminary design. You can do the basic design of everything. Determine the main principle, engine size, and the like. Contract design is a little bit more detailed way, and it's a very specific to this U.S. naval warship construction, because U.S. Navy do not construct their ship. They give contract to shipyard, which is not their own. It's another company. But in order to sign a contract, you have much more information than preliminary design. Okay? And in order to actually construct those ships, you have to have much more information. Welding length, cut length, and the logistics plans, and on the shipyard, and all other things. So it's a very, very effort requiring design phases, and we are not going to do that in the class. And actually, your first team project will be about feasibility or conceptual design of wind turbine, and your second team project will be a part of the preliminary design. So we are usually in this class we'll discuss about these two, mixture of these two. But it's a quotation from work of Seo. Can you guess who is this Seo? Yeah, our president. He said this one. The bottom line is, preliminary or conceptual design requires very minor portion of all the efforts, but it determines all other things. By importance, preliminary and conceptual design is most important thing in all of design processes. If you mess up at the upstream, then it is really, really difficult to change it in later downstream processes. And he keep insisting that all the highly educated engineers are not working on these most important stages, because they can do a fancy thing like a structural analysis, buckling something, fluid structural analysis, or something like that, which is not required in feasibility test or something, usually in second or third stages, but he keep insisting that these highly educated engineers should take charge of that most important feasibility or conceptual design stages. And I agree with him. It's you can see this type of chart in many places. As time goes, your design information accumulate and keep increasing. However, your freedom to change the design will be exponentially decreasing. And actually, these stages are your conceptual design stages. It directs all the downstream design processes. Most important. So I want to emphasize this part, how you can well design in your conceptual stages are my concern, and I will put a lot of time explaining any systematic approach to help you in conceptual design processes. And if you remember, in the next classes and mostly on September, the classes are talking about QFD, AHP, axiomatic design, or something like that. All these are tools to help you in feasibility and conceptual design stages. Okay. After that, once concept is selected, you are supposed to do a preliminary ship design, ocean systems design. And first thing is clarification of task, what to do. Okay? Okay. And you have to have the result of your conceptual design like this. Performance requirement, operation requirement or something. What rules to satisfy? Because it's ocean systems, it is kind of specific to our own industry. There is a classification society. Korea has Korean Register of Shipping, KR. DNV is Norwegian Classification Society. ABS, American Bureau of Shipping. It's a kind of a huge system. You have to satisfy some rules. For example, if you're going to build some building, there is a rules to follow, right? Safety rule, something. Then you have to get approved by this society. Once your design is satisfied, completed, and then you can start to build something. Same thing here. Ocean systems engineering, shipbuilding industry, there is a classification society. One different thing is, because building is constructed inside of some country, but for these ocean systems, even though it's built in one country, it will be operated on, because it can move on the other country or in many other countries. So the ship owner has the right to choose his own classification society. Okay? And the main feature requirement and other things should be determined. And description of main features of a selected solution should be also clearly described. As your concept design, it's a kind of brainstorming. How about this design? How about this design? And you have to compare these two, and you have to select one better thing. And for that selected design, everything should be documented clearly. If it's not, you will be lost. Usually, such ocean system, a huge system, will take a lot of time and lots of men working together. Okay, thinking of you work with 20 other engineers for about 2 years. How can you remember what this guy said about 18 months ago? No way. Okay? Have to document everything. Okay? As the time flows and more, you are now supposed to do this kind of things. Main dimension, L, B, T, draft, and other things, displacement, general arrangement, how every machineries are located inside of your system, and preliminary lines. I mean, the ship has a very complex curvature, so there is some specific techniques to express those complex curved lines, curved surfaces with 3 different drawings that we call lines. Because the drawing has full of lines and have to calculate the weight. And somebody may say, oh, what's the big deal of the weight calculation? We can just apply this summation operator to everything. Yeah, but it's not that easy. For example, what's the weight of our new sports complex? What's the weight of this building? That's the size of the question we have to answer in this one. Okay? We can, well, in a simple sense, we can summarize everything. Chairs, humans, tires, and everything, but it is not practical, so there is some kind of systematic methodology to help you there. And also, if you're designing a ship, it should float. So, have to check it will really float or not. Hydrostatic calculation, or it will capsize or not, you have to calculate it. Because, you know, if the small disturbances tilt your system, that it will go bad or it will restore, that is a big issue. Have to calculate your system has your self-stabilizing ability, riding moment, or we call it stability, static stability or dynamic stability. You got to basically calculate. And cargo condition, dead weight estimation. Basically, ship is designed for carry something, calculated. Tonnage, electric load balances. As I mentioned briefly earlier, it's interdisciplinary. Okay, you got to think of everything. For example, electronic wiring, you have to design in a systematic way. Okay, to design a ship. Also, production hours. For example, it's like what would be the man hour to construct this new sports complex? Got to answer it in order to make a contract, because the labor charge is based on the man hour requirement. Okay, sketches of very important thing, engine rooms or something like that, and price estimate. You got to accurately estimate the price before start to make a contract or master plan for the production schedule. Okay, all these things are supposed to be determined in conventional preliminary ship design processes, but because we are in the university, we are not going to do everything. Usually, price, production schedule will be omitted in this class because it's out of scope. but major part of these subtasks should be covered in the team project number 2. Okay.